Hi all, welcome to another video of the subject DC machines and transformers based on KTU syllabus, and we are on module 5, and today we will discuss about the tertiary windings. So we may be heard about the only two windings used in transformer, that is primary and secondary windings, but there are transformers in which there will be three winding and third additional winding is there. It is called the tertiary winding. Okay, so it will be in addition to our primary and secondary windings, an additional third winding will be there. It is the tertiary winding. So such transformers are called as triple wound transformers or three winding transformers. And what may be the main purpose of this tertiary winding? So the tertiary winding may be serve any of the following purpose. So the first one is to supply the substation auxiliaries at a voltage different from those of the primary and secondary windings. So in a normal transformer, primary and secondary voltage levels will be there, but if we need to operate a substation equipment at a different voltage, we have to include an additional winding, third winding in the same transformer, and the third winding the voltage will be different. Okay, and to supply phase compensating device such as condensers operate at a voltage which is different from both primary and secondary. In that case also we are applying that tertiary winding for a third different voltage. Okay, and to interconnect three supply systems operate at different voltages, to interconnect three supply systems at different voltages, and to load large split winding generators, and to measure voltage of a high voltage testing transformer, and also in star connected transformers to allow sufficient earth fault current to flow for operation of protective equipment, to suppress harmonic voltages and to limit voltage imbalance when the main load is unsymmetrical, that is when the main load is unbalanced. Okay, when the main load is unbalanced. So when the main load is unbalanced, there may be a possibility of third harmonic current, and also the zero sequence current will be there. So if you are providing a tertiary winding, it will provide a path for the short circuit currents. So we can limit the short circuit current by using that tertiary windings. Okay, and it is also called as auxiliary winding when it is employed for supplying an additional small load at different voltages. Okay, if the application is like this, that is to supply an additional small load at different voltages, it is called auxiliary winding, and also it is called as stabilizing winding when it is employed to limit the short circuit current. Okay, and the principle of operation. So the principle of operation is same as a two winding transformer. The only difference is here we are having a third winding. Okay, so we know that in a normal transformer the primary acts as a magnetizing winding. Here also the primary will act as a magnetizing winding, and it produces the flux. So the flux links the secondary as well as the tertiary winding. Okay, and induces EMFs in both the secondary and tertiary windings depending upon the number of turns in the secondary and tertiary. Okay, and also in this three winding transformer, the MMO of primary. Okay, normally we know that in a two winding transformer the MMO of primary will be equal to the MMO of secondary. Okay, they are balanced, but here the MMO of primary must balance the combined secondary MMO, that is the combined MMO of the secondary and tertiary winding. Okay, so we can say that I1 N1 is equal to minus I2 N2 minus I3 N3 plus I0 N1, where the I2 is the secondary current and I3 is the tertiary current, and we are considering the I0 is the load current. Okay, so in effect when we are solving that, when we are dividing it, the first equation by N1, it will become I1 is equal to I2 dash I3 dash plus I0, where I2 dash is equal to minus I2 into by N1, and I3 dash is equal to minus I3 into N3 by N1. So thus in a three winding transformer, there occurs a simultaneous transfer of electrical energy to two secondary circuits, that is the secondary and tertiary winding. And when we are talking about the construction, so we know that in a three winding transformer, three set of windings will be the at three all these three are operated at three different voltages: primary, secondary, and tertiary. Okay, so the voltages we can termed as the low voltage and medium voltage and high voltage. So sorry, it is not HHV, it is HV, high voltage. Okay, high voltage. So two different arrangement is possible there. Okay, there is LV, MV, and HV, and MV, LV, and HV. Okay, so in both these cases, the HV winding, that is high voltage winding, will be the outermost one. Okay, normally we have learned that if you are having a core, okay, normally if you are having a transformer like this, okay, if you are having we will place both the primary and secondary in both the limbs. Okay, so for in the case of an installation purpose, okay, we will place the low voltage winding first near the core, and above the low voltage winding we will place our high voltage winding. Okay, so if we want to place a high voltage winding just around the core, we have to use large amount of insulation because it is a high voltage winding, so we have to use large amount of insulation there. So normally in all cases, practically in all cases, no, we maybe place the high voltage winding in the outermost layer. Okay, the outermost side. The figure can be shown like this. Here, this is the core. So in most of the cases, HV will be the outermost one, and the LV and MV, okay, both can be both are connected just a point adjacent to each other. Okay, that is LV and HV are adjacent to each other, and either of the two are placed nearer to the core, or LV winding or MV winding can be placed near to the core. Okay, and these two arrangements is possible in three winding transformer: low voltage, medium voltage, high voltage, and medium voltage, low voltage, and high voltage. Okay, so that's actually written here. So these are the main two arrangement here. And also when we are talking about the equivalent circuit of a transformer, this is the primary side, and this is the secondary side. This, we know that the resistance and inductance are the corresponding leakage reactance, and resistance is used to represent the copper loss there. Okay, and in the both secondary and tertiary, we are having these inductance and resistances for representing the corresponding copper loss and leakage reactance. So this is the case, this is the secondary winding, and this is the tertiary winding. Okay, so normally we will draw the equivalent circuit like this. Okay, so here we can say that the effective impedance, okay, that is the impedance between this point 1 and 2, Z12, we can call it as Z12. So Z12 will be the sum of this Z1 and Z2. Okay, so that's actually written here: Z12 is equal to Z1 plus Z2, and the short circuit impedance of the winding 1 and 3. Okay, 1 and 3 will be 1 and 3 will be, what will the value? Z1 plus Z3. And also the impedance between the 2 and 3 will be Z2 plus Z3. Okay, so these are written here. So by solving this equation, we can simply find the value of Z1, Z2, and Z3. Okay, so Z1 is obtained as 1 by 2 into Z12 plus Z13 minus Z23. So likewise we will obtain Z2 and Z3. Okay, so just be careful about that, the equivalent circuit and the values of the impedance and all. Okay, so I hope all of you understand the tertiary winding and its construction principle of operation. Okay, so thank you.